Hello, everyone, and welcome to the Indiana Nomad Podcast, sponsored by DataShapes, the experts in all things signal and waveform AI. I am your host, Logan Selby. This podcast will introduce various experts from different industries from around the globe to give their thoughts on technology and how it has affected them personally and professionally. We will spend time understanding how innovation is changing their industry and where each guest sees the evolution going in their respective field. I hope you enjoy and feel free to follow us on Instagram, Twitter, or our YouTube channel at Indiana Nomad. Hello, everyone, and welcome to the next episode of the Indiana Nomad Podcast. Today, I'm joined by Junaid Islam. Junaid is one of the board members of XQ Message, a secure comms company, and we're lucky to have him. Junaid and I are doing some work together, and we're putting a blog together along with this podcast. So we're going to have some written content that we're going to associate with this podcast that is going to go out simultaneously. But luckily, we got Junaid to come on today to tell us a little bit about what we're going to be talking about together. And so we'll kick it off and let Junaid tell you a little bit about himself. One connection we have is Junaid has actually done some work in Indiana in the past, so it's great to have him on the Indiana Nomad Podcast, and we have that nexus. So that's always fun. But I'll kick it over to Junaid to let you hear a little bit about his background.
Hi, well, thanks for having me on the Indiana Nomad channel, a very prestigious podcast, top rated in the state of Indiana and soon the world. My name is Junaid Islam. I've been in secure comms 35 years. I started all the way back in the first Gulf War in expeditionary communications. After that, went on to create protocols, helped create MLPP, which is used in weapons control system, actually, and still used in the Patriot today. Then did MPLS routing at Cisco, then did mobile IP v6 for net-centric warfare. Worked as a contractor at the intelligence community to help create something called C2S access control, which became Zero Trust. And now do a couple of different things. Still consult with the US government and work at XQ Message as a board member and part-time CTO. And as Logan mentioned, did actually work in Indiana. I helped in the early days of the Indiana 5G zone, which was a great project between the state and the local universities on innovation and doing some cool things. And then more recently, helped create the security for Discovery Park, which is a fantastic new cool housing complex at Purdue University. So consider myself an honorary Indiana resident.
No, that's perfect. Me being an IU grad, though, the Purdue thing kind of throws me for a loop. But
Okay, well,
no, just there's always a rivalry there. But Purdue's obviously a great university. Okay, well, so let's dig into what we're talking about. So the title of our blog, which is going to be a multi-part blog, is called "The Threat of AI: Is Chat GPT Stealing Your Data?" So if you've been following the news lately with ChatGPT and what's going on legally for them. They've been entered into a court case revolving around data poisoning, privacy, a lot of different concerns there as it pertains to ChatGPT, the technology in general. We'd love to get your thoughts on it, Junaid, and we'll kick it off and let's dig into it.
well, first, let's just talk about the big breakthrough with ChatGPT, because we have to kind of look at that to see why it is so fun and cool to play with. ChatGPT is something called a large language model. And as the name implies, ChatGPT works by ingesting massive amounts of data and basically looking at correlations between the data. Now, ChatGPT itself is not conscious. A lot have said, is it thinking? It's not really thinking in the human sense of thinking, but what it does is it's very good at figuring out what humans, how they connect words. And when a human being asks a question, it plays it back, and sometimes the insights are very powerful. So that's the good part. The part that has now become slightly controversial is ChatGPT's database of billions of fields actually came through ingesting data across the open internet, which it continues to do. Moreover, when you ask ChatGPT a question, it actually remembers the question because it looks at your interaction and it updates the coefficients in the data model basically instantly. So now with ChatGPT and other hosted AI services, a couple of issues have come up. One of the biggest issues is privacy, and we see that in the use of AI in smart cities as these systems become better and better, not just for language. We see this in smart transportation and energy systems, where the smart transportation system knows who you are and where you're going, and the energy system knows exactly, what you're doing in your home. And this is just the beginning, So, on a parallel track, the Department of Defense is looking at AI for weapons acquisition and fire control systems as a part of CJAT C2 for the obvious reason, it's super fast. So I think we have to be really careful as we start looking at hosted AI solutions because they're very magical. They can do things in a split second that from a human perspective, it's very hard for us to do. But we also have to look at the lethality and the fact that they do make mistakes. They can ingest the wrong data. They can also take your data, which you think is private, and then serve it back to other people. And of course, if we're thinking about doing anything real time with it, we have to be careful. It's one thing to play with ChatGPT and get the wrong answer. Now imagine a hosted AI controlling a city and controlling a power plant, and then the wrong answer shows up. So um, this is going to be a part of ongoing dialogue as we learn about this technology and its potential uses.
Sure, sure. And so, one key point that you mentioned was hosted services. And so another way that I like to characterize that is, centralized. So, hosted being could mean in the cloud. Usually that's what it means. But it could mean, just a centralized place where all of that data resides, where the billion parameters that's being used to run the models exist. And so there's, you and I have had conversations on the difference between a hosted or centralized approach versus a decentralized approach. Obviously, I'm a big fan of decentralized because that's what we do at DataShapes. So, we make embeddable products that can reside at the edge, and instead of streaming all of the massive amounts of data back that you're collecting, which is usually unsecure, by the way, which you know all about, you can actually do a lot of that processing that is done in a centralized perspective. When it comes to ChatGPT, you can actually do it decentralized, so at the edge, and then you're only transporting back the insights. So that's what we're excited about, and I know that's kind of where this conversation is going. But what are your thoughts around the decentralized versus centralized approach as well?
Yeah, so that is a great topic. So one of the things I hope people get out of this podcast is, as we look at hosted AI models, large language models, actually that's not the only approach to AI. The fact, we as humans have choice. We actually have choice in terms of how these technologies are deployed, how they're used, how they're configured, how they manage the data. So, a couple of things I want people to get out of this podcast and kind of really integrate into their thinking is an alternative to a hosted AI solution where it ingests data and then basically retransmits out all your personal information. Is actually a decentralized AI approach. And this in the past was seen as very difficult, but there's really been big breakthroughs in CPUs. I mean, if you just look at your mobile phone, in the last few years, it's become, a supercomputer. And now you have basically CPUs which run in the gigaflop range. I mean, if you look at the new NVIDIA chipsets, right? I mean, these are true supercomputers in the truest sense of the word. The big breakthroughs, they're small form factor. So unlike supercomputers that take up a big room and need air conditioning, these things can run right at the edge. And why is that important? As we look at mission critical applications like running a city, managing the traffic, managing air conditioning. I mean, I just use that as a simple example. Decentralized AI is much more elegant than moving all the data from all the residents of a city into a cloud. The other benefit of a decentralized approach is we can also anonymize, redact, and secure the data right at the edge. It is much more difficult to protect data, raw data, once it's moved into a cloud on a post-processing basis to encrypt it versus basically filtering it right at the edge as soon as it's grabbed. That's much more elegant, and it also creates what we call a chain of custody. We can actually see the data being processed and redacted. So a really simple example, when we were working at Discovery Park at Purdue, we put a camera up, and the idea was it was just a test to see if one camera could support different applications. And one of the concerns is, would this be spying on everybody? So, we did a little prototype. We actually put this out on the road where we actually ran the AI program, not something as sophisticated as DataShapes. This was kind of open source. But the point is, we could run this within the camera because most new cameras are Linux servers, and basically just output the number of cars passing the intersection, which is what we really needed for traffic control. We didn't need pictures of the cars. We didn't need pictures of the license plates of the drivers. So as we look at how we build a smart economy, which is happening across the United States and around the world, I think decentralized AI with security integrated in, and specifically zero trust security, is far more elegant. On a parallel track, as we look at the work the Department of Defense is kicking off with combined JADC2, which is their new architecture to basically link all of the armed services and the intelligence community to really, respond to threats instantly. You find a decentralized AI approach with zero trust is actually the only solution, because the last thing you want is for someone to stop operations because they've lost the internet, or the satellite is down, or is jammed, or there's interference, or undersea fiber has been cut just by accident. So decentralized AI is critical to be allow your systems to do target acquisition to keep on working. So I think we need to think about these things carefully, and also realize there are choices. And this is something policymakers need to internalize, whether you're at the state level or at the federal level or at the Department of Defense.
Sure, sure. One other thing that I like to bring up when I'm evangelizing this concept is, everything you mentioned, then also the cost that's associated with, using a hosted based service. The cost, the compute required to do a lot of these extravagant type building these extravagant type models. Whereas, if you're doing something elegant at the edge, it's relatively inexpensive. And then the data required, you're only transmitting the insights that you need. So the amount of data that's being processed is a lot less. So the pipe needed to transmit the data it could be smaller. There's a lot of things that can take the cost down by orders of magnitude. Obviously, you're going to be scaling the type of technology at the edge nodes, but still the relative cost is a lot less than what you would be spending in order to transmit the amount of data needed, and then all the processing and compute required at the centralized node to do the processing. So it's a cost savings aspect to it too. So I always like that, throw
Yeah,
that in
yeah,
there
and
for an ROI perspective.
you know what you said about the cost is actually becoming a bigger and bigger issue. And that's because as you look at smart city transportation manufacturing applications, and if you look at what's happening at the Department of Defense, the big trend is high resolution video. It is just showing up all over the place uh, because it's great. We're also seeing new kinds of connected sensors, sensors for temperature, sensors for motion, which again are showing up everywhere. We're seeing new kinds of transformers, which are adaptive transformers, which really show up in green energy applications because windmills and solar are generating power as a waveform, and that has to be integrated to whoever the users are. So if you think about this high resolution data, moving it all the way across a state, say Indiana or the country, just to move it all the way back with the output actually becomes a big problem because these high resolution sensors really are generating, at the bare minimum, gigabytes per day per sensor, especially when you get to imaging systems. So being able to do your AI at the edge and then only transmit the insights is kind of a big breakthrough because, as cheap as connectivity is, you'll find out that you can run out of connectivity really fast. The other thing is, if you look at smart transportation applications, inherently smart transportation is always spread across a geographic area. So finding high bandwidth, across a state is very difficult. The one of the projects we did at the Indiana 5G zone had to do with agriculture or big ag, as they say in Indiana, where they of course have gigantic farms, and we were looking at things like the level of the maturity of the crops, and also looking at the dryness or the water level to see if they should optimize that, and also looking at things like pests to reduce a number of fertilizers and pesticides. So one of the things that quickly happened in this project as we were doing it quite far is, we couldn't get any connectivity to connect to remote machine learning programs because we were transmitting the video all the way to basically tell the farmers. I mean, it's a great example where decentralized AI, much more elegant, much more practical, much easier to deploy on agricultural lands to do, digital ag or smart ag, where a hosted application just wouldn't work. I mean, you're taking all your temperature feeds and water feeds 100 miles just to send it back to the technicians on the field, right? So
Absolutely.
yeah, I mean, if anything, I think the smart economy will rely much more on decentralized AI than hosted AI, even though at this moment in time, hosted AI is definitely getting all of the publicity and social media draw. But,
Sure.
you know,
No, it makes perfect sense. It makes perfect sense. Well, so we've hit, in passing throughout this conversation so far, we've hit a couple areas, and so I kind of want to circle back, and I want to make sure we definitely hit these three areas because it's going to be areas that we talk about in our blog that we post, our multi-series blog, and so those three areas being, mission critical data. So we've referenced the DoD a few times, so I definitely want to hit that. I want to talk about some smart cities as well. We've mentioned that a couple times too, so I want to make sure we dig in on that. And then closing out with logistics and manufacturing facilities is kind of where I want to end up. So let's kick it off first, though. Circle back. We mentioned CJADC2 and what the DoD is doing and how they're currently trying to orchestrate this new concept. And I think the timeline they've put on it is by 2030. Is that right? They're wanting to get somewhere before
yeah,
2030. And so we've started off the conversation. So the decentralized approach is something that they're going to have to adopt along with zero trust data in order to achieve this concept of CJADC2. So making sure every sensor and shooter is connected across the battle space. So whether it's a Navy ship. It's connected to an Air Force aircraft. That's connected to a Space Force satellite. That's connected to a soldier, U.S. Army soldier on the ground. How does all those things connect together and talk together in a secure manner? So that's kind of the concept, I think, at a very, very high level, obviously. But that's where they're wanting to get to. So let's dig into that a little more. So what? What's just give me your opinion overall. I know the timeline 2030. That's pretty sporty, as I would say. I know that's rapidly approaching,
sure.
and a lot of work to be done.
So, the big question to ask is, before we talk about CJAT C2 is why are we doing anything in the first place? I mean, and you really, a lot of this is being driven by the war in Ukraine.
Mm,
The war in Ukraine is, I would say, the first modern conflict of our era. Where we see a lot of network technologies, such as drones. I mean, we're seeing, drones being used by both sides. And what's interesting that these drone networks are using a mix of private wireless networks, such as microwave, commercial mobile services, and commercial satellite services. So for the planners at the Department of Defense, this has kind of been a watershed moment to say, you know, this is really the nature of war. The other thing we're seeing in Ukraine is the use of social media for intelligence gathering, and this is totally novel. So typically, when you think about conflict, you think about very expensive satellites deployed by the U.S. government doing high resolution imaging, and those systems are in play here. But the other thing we're seeing is on Twitter, people basically tweeting live from the front line exactly what's happening the split second it's happening. And not only are you getting a feed live from the front line, unedited, at the same time, people in the US intelligence community are getting it, but you can actually ask a question back. I mean, the thought that you can actually communicate with a soldier on the front line and ask him how things are going and ask him to move the camera so you can see something else is kind of a big change. So what does that mean for the Department of Defense and combat? So there's two things. One, the notion or value of being connected has really gone up. That being connected is really good because it allows warfighters to directly communicate with intelligence analysts and the leadership across not just armed services but also coalition. All American operations are coalitions. The other thing is being able to ingest not just classified surveillance data, but ingest commercial open source data, whether it's social media or blogs or other things. So if you take these two mega trends or shifts, this gives you CJAD C2, and this is why it's so different. So the fundamental difference between CJAD C2 and everything else armed services has done for the last 100 years is we're talking about a system that can use any available network. It can use DoD networks, it can use commercial networks, it can use satellites, it can use mobile. It can also ingest any kind of data from anything, its own sensors, drones from the Air Force, but also what are people posting in social media about a conflict and merging that data stream in. So this is kind of revolutionary, but it's also needed, because the nature of war has changed significantly. So I think that this is going to be a long process, and I think the idea that we're going to get everything done by 2030 is a stretch. Having said that, I think on a pairwise basis, you'll certainly see groups such as, I'm just using this as a random example, the U.S. Marines working with the Air Force to get imaging delivered right to people on the ground, but also merging in imaging from commercial sources, delivering it right to the Marines. So I would expect within the gigantic architecture of DoD, a lot of pairwise or between different groups, as well as pairwise across between the United States and coalition forces. For example, if you look at the U.S. Navy operating in the Pacific, along with Australian and Canadian warships, working out a way to share their, for example, RF data. What are we hearing in terms of RF interference or jamming out on the ocean coming from fishing boats or random people, and sharing that so we have a situational awareness. That is something we are going to see, and we're going to see, and in fact, that kind of work has already started. So we're going to see that, and certainly AI has a huge role because if we just take something simple like looking at the RF inputs that different warships are picking up, being able to correlate that as a human operator is next to impossible. I mean, if you're just looking at, I've got some noise here and I've got some noise here, the ability of AI to basically plot against a map and says, well, given the noise pattern, there's probably a rogue transmitter over there, 35, 20 miles that way. And then you look on your imaging system, and lo and behold, you see a fishing boat with a lot of big antennas. A little suspicious, right? So the notion of the value of AI in combined JADC2, I think is huge, and we will start seeing um, work in that area. And the thing I want to stress to people, it's really driven by what we're learning from the Ukraine war
Yeah.
in how networks are being used, and how commercial technologies are blended in with military technologies.
No, no, I definitely agree. The multi-domain fight is something that is it's apparent now that that's going to be any conflict that we're involved with, whether it being a conflict that we're providing aid to, like in Ukraine, or a conflict that we're actually involved in. It's going to be a multi-domain fight, and the amount of innovation when it comes to autonomous systems, even, are going to have the capability of ingesting various amounts of data from different sources in order to do like tipping and queuing as they operate together in a swarm type of environment and in groupings, and being able to cross talk across those different domains. It's going to be critical. So definitely agree. So transitioning to our next topic, we brought up smart cities. So just kind of talking through, and like I said, the reason I want to hit on these topics is because we're going to mention them in more detail in our blog and in our written format. But just to ensure we cover them and talk about where our minds are at as far as a decentralized approach to AI for these different topics or use cases. Secondly, I wanted to get into smart cities. So let's discuss that a little bit. You mentioned some transportation examples a little bit ago, but let's flesh that out some more.
So the big topic in smart cities right now, having to do with AI, and we're seeing this at policy meetings and conferences, is privacy. People are rightly worried whether these smart systems are really going to spy on them or serve them. And there's a bit of history in this topic, and it has to do with China. China is actually the leader in smart cities. It's actually not the Europe or the United States, and they deployed all of this really to monitor their own people. So a great example of this is a few years ago when Hong Kong was just being taken over by China. There was a number of protests, which everybody saw. And was the interesting thing is the day after the protests, people were arrested, even though they were out on the street, because the traffic cameras the Hong Kong police had set up really to look at traffic in Hong Kong, and uh, were repurposed by Chinese intelligence to look at the people, not the cars, and pull their identities, and then actually go to their homes and arrest them. So I think that rightly frightened a lot of people to say, oh, you mean those cameras that look at cars can look at people? And the answer is yeah. And those are high resolution cameras, true. So I think as a global community, not just in Indiana and others, I think it's really critical to build in privacy into the architecture. Privacy and how you handle data governance cannot be an afterthought.
Mm-hmm.
So the question is, well, okay, that's really great. I've got a bunch of old cameras, and they are what they are. I think this is a great example where decentralized AI is huge, because to manage a piece of highway, you don't need all the video feed. What you need is you need the number of cars and their velocity and which direction they're going. This kind of processing can be done right at the edge where the cameras are to optimize that, and then the insights can then be shared on a broader basis, say across a state, to say, well, this is what's happening in Indianapolis, this is happening in another city, this is what's happening on the main artery between, Indianapolis and Chicago. You don't need to send pictures of, people in their cars and their license plates. So I think smart cities is a place where, by policy, the people need to look at building in privacy, and then which is common sense, and then the implementation of that privacy then is handled by decentralized AI. So, there is always raw data, but the whole idea is that the raw data is processed to, say, manage a piece of highway or a set of intersections, and then it's deleted. And then all of the shared data, we use a zero trust data model, so the output of the system can only be read by other authorized programs. So, the idea is that, someone can't reverse engineer and use it to track people. So, when it's kind of interesting where when we talk about combat operations, very different than managing a city. But once we start looking at the issues around, well, how do we handle data? How do we make it mission critical? How do we handle privacy? We end up with the same result of a
Mhm.
kind of
Yeah.
decentralized approach with integrated security or zero trust.
No, that makes perfect sense, and it's probably the same to say for the next topic that we were going to discuss is logistics, manufacturing type environments. Very similar, so it's going to be a very similar setup to a smart city environment, which then extends into the mission critical environments, like we mentioned. Obviously, use cases are different, but it's still being applied in a similar fashion. Obviously, let's maybe talk on that for a minute or so, and then we can.
Sure. So
Uh,
yeah, again, the interesting thing is when you think about logistics and manufacturing, at the 100,000 foot level, you say, oh, there's no similarity between weapon systems, energy system, and what we find there is, because if you look at manufacturing systems, let's look at cars, we actually find a gigantic supply chain behind it. I mean, someone's making the tires, someone's making the rubber for the tires, someone's making the brakes, someone's making the parts for the brakes. So the use of AI to optimize the logistics is actually huge. And in large scale manufacturing operations, if you can do 1 or 2 percentage points increase in the output rate, that's huge. I mean, it turns into billions of dollars really quickly. So what you find is, again, there's a theme here where you don't want to send the raw data from factory to factory to factory. Oh, this is what's happening on my conveyor belt, to the guy who's making the brake part. I mean, he's not going to know what to do with it. What you want to do is you want to say, well, this is what's happening in terms of my factory, and this is how we're optimizing it. And, here, you 40 people who are now supplying me, I want you to change the rate at which you resupply me. Can you give me 20 parts per day versus 23 parts per day at this rate, right? So again, we have a theme here. We want to do the raw data processing in a factory. Uh, in terms of optimizing the manufacturing, managing the robots, but then we want to share the insights securely with all the downstream suppliers, and let that actually cascade from supplier to supplier. One of the interesting things we're also seeing is the integration of smart manufacturing and smart transportation. One of the big projects actually being championed in Indiana and we're going to see this in the next few years, is autonomous vehicles moving parts between factories at night when there's less traffic.
sure.
And Indiana is actually at the forefront of that type of work, right? So again, very different industries, but we're seeing themes here. And probably the most important thing I'd want people to get out of this podcast is the ChatGPT model. While fun and cute and great, is not the only model, but more importantly, probably not the optimal solution for mission critical applications, whether we're talking about national security applications, big ticket infrastructure applications, or manufacturing applications.
Great, great. Well, thank you, Junaid, for your insights. They're encrypted. No, I'm just joking. But no, we appreciate your thoughts, and I welcome everybody to check out our blog series that I mentioned. That's going to be accompanying this podcast. We'll have our first blog that accompanies this out with this podcast, and then the next few will come out shortly after. So make sure you follow, and I'm sure Junaid and I will both be sharing on social media as well. So check it out and let us know what you think. But thanks again, Junaid. I appreciate you coming on.
Thanks for having me.
All right.